Today we continue and we are getting close to the end of this series about working with Git from the terminal. And when I'm saying we're getting close to the end, I mean to some of the lessons that, some of the chapters that we're following from a lesson from Code Refinery. We've seen everything all the way to sharing repositories online. And I would like to talk one more time about sharing repositories online before we go to the last meetup about inspecting the history. And the reason why I wanted to cover one more time is because it's kind of the most important aspect of what we do when we collaborate with Git. And it's all under this umbrella of working with a particular pattern or a particular workflow, and it's called the GitHub workflow. When we are familiar with it, it is the idea of having just a single long-lived branch called main or called master or something like that, and then having tiny branches that are short-lived where we add some specific change and then we merge it via something that we call pull request. So that's it. I'm going to close that. And last time we talked about one particular setup for the remotes that the book Happy Git with R calls hours. So they gave this name to this specific Git remote setup where everyone in the team has access to the main repository. And by access, I mean that they have the privileges to push directly to the master branch of that repository. So that is the case for all the repositories that we work, and it is the simplest remote setup that we can have that gets the job done. I used to be a bit resistant because I didn't understand much about how we could keep the main repository clean by setting one option that automatically deletes contributed branches. But now that I've learned that, I think I endorse every time more the idea that Alex has been kind of pushing for a long time, which is the idea of just keeping one main repository, and instead of creating forks, pushing pull requests directly to it. Always, in the GitHub workflow, you never push to master, you push to branches. Those branches travel to the main repository via pull request. But there is two options. The option that we discussed last time, and I showed an example where you have this setup called hours. And the setup that I would like to talk about today to expose its complexity. And I still think it is great for some circumstances, but I'm every time more convinced that for what we do, maybe the simplest approach works perfectly fine. Today, I want to talk about this more complex setup that is called fork of hours, and many of us, use it, and you have to use it when you work with collaborators that are external from 2 degrees. That is because with this specific workflow, even if someone does not have privileges to push to the master branch of the main line of development, they can still contribute code. That is because they create a clone of the main repository into their own user account, and to that thing we call a fork. And then, so that could be this line moving to the right. And then they create a clone of their fork locally into their computers. They do the changes that they want to submit. They push those changes to their fork here, and then they submit the pull request back to the main repository. So again, that is a must when people that want to contribute have not the privileges to push to the master branch of the main repository, but it is optional in our case, for example, where we all have, or generally we have access to push to the master branch. So what we do is we create branches, we submit pull requests, but directly through to the main repository, so they become simpler. But I wanted to talk about this workflow because it is important, it is useful. In some cases, as I said, it is the only way you have to get your job done. And also because I continue to learn things about the complexity of this setup. And today I was kind of stuck in something and I kind of actually learned something new. And in that complexity, I have been pushing for many sessions now the idea of abstracting those low-level details that create so much friction by finding a tool that works for you and automates some of the processes that otherwise you have to kind of keep on your brain. So those tools are things like, for example, if you use R, maybe they use this package, does a lot of these configurations automatically for you. Or if you use the command line application called GH stands for GitHub. It is a command line application that GitHub is developing and it's working great. And every day is kind of getting better and better. Same thing, it does a lot of these things that, it's really complex, but if you use a tool, they just, automate all those processes for you. So the idea that that you can, so the most important idea that creates some friction in this complex setup is when you are the maintainer of the mainstream repository, or you are the reviewer of that repository, and someone contributes a pull request from a fork. So when it's still open the discussion, and if you should or not add changes to a pull request that you didn't create, when you do, and I often do, you have to have that connection. You have to have access to push changes to a pull request that is hosted in a fork. And that is not trivial. That requires some specific setup that doesn't come by default, and you have to do a few things to make that happen. So that's why when you go to the book, for example, Happy Git with R, eventually you see in the part where there is patterns for everyday kind of Git life, there is a section that points to this one GitHub documentation that says how you could actually do that. How, as a maintainer, you could push, or as a reviewer, you could push commits to the fork of someone that has contributed code. And the idea is very, very simple. It's just that you go to their fork, you get the clone link, and then you create a new, you clone that directly from their fork into your computer. And because you have access to the main repository too, automatically you gain access to push directly to their pull request on the fork. But that creates basically, generally you have your own clone as a maintainer, as a reviewer, and then you're working on that one. But then, if you have to do what these instructions say, you end up with another clone somewhere else in your computer where the remote origin is pointing to the fork of that contributor. So that is possible. It is very simple and it just works, but it's kind of like, I don't know, hacky or something. So you're welcome to come to this documentation to convince yourself that what I'm saying is actually, you can try. But what I recommend instead is just to use the tools that do that, all those connections in a way that it feels very, very fluid. So I'm going to demonstrate that because so far it has been a lot of talking and very abstract. So I would like to do a little example with this repository called demo. We have it there in the 2 Degrees Investing. And it is not important to know what this repository has. It's just one way to show you the tools and to show you the workflows. So I'm going to move this browser to the left, and here to the right you will see that I'm pointing to the exact same address, except that the browser looks a little different because here I'm logged in as someone else. So in this account, on the right actually it is I'm logged in as someone else, and here I'm going to have a fork. I have a fork of this organization. So let me expand this. So what I'm showing you here again is that I'm accessing this repository to which this user called Mauro Lepore, happens to be me, wants to make changes, but this user has no privileges to push commits to the main line of development of this repository. So we are kind of pretending that it is an external collaborator, someone that is not in the 2 Degrees organization, or it is but has for some reason no access to push to master. So this person has forked, I believe. Yeah, there you go. So this is the fork of this person. So we can go there, right? And this is the page. As you can see, I'm now on the repository that has the same name of the repository, but it is on the user account. It's not on the 2 Degrees Investing. And you can see also here, let me make this a little bigger. You can see that we have a reference here that says fork from 2 Degrees Investing demo, right? So this user, right, goes to a file and changes it. So let's say that, it goes to the README file and they want to edit that file. Because they are on their fork, they can do it. They click here, on the edit button there, and they can, add changes to it. And the same thing could happen, I think, if they go to the main repository here. GitHub will also allow them to edit files from there. I mean, usually this is the kind of thing that one could do from the terminal and then push. But for this example, the aspects that I want to demonstrate on the terminal come after this. So the first submission of the pull request is not something I'm interested in showing too much, because it's something that we've been doing quite a lot already. So I'm showing that, this user, they go to the 2 Degrees organization and to the repository demo, and they look for a file that they want to change. In this case, the README file, and they actually have access to edit it, and you will see why in a moment. So, they add a few lines and say, bye, whatever. So the reason why is because when they propose the changes, that change was not gonna immediately get to the master branch. Instead, it's gonna create a pull request, or it's gonna give the user the option to create a pull request. And as you can see, automatically GitHub has chosen a name for a branch. It has created a branch, in this case, automatically. But if you were doing this from the terminal, you would have to create, the branch yourself and then add the change that you want. Again, here I'm just doing the pull request in the simplest way possible. As you can see, we confirm here the change has been done in this branch called patched 2 in the repository demo of the user account Mauro Lepore. And this pull request proposes for this change that exists in this branch to be merged into the master branch of the repository demo in the 2 Degrees organization. This should be nothing new to you right by now. We create a pull request. I'm not going to add any message there, just to have the pull request done. Okay, so I'm going to move this to the right. And here to the left, I'm going to refresh the browser logged into an account that has privileges to do just about anything to this repository. So as you can see, there is a pull request there. The pull request is called update README, right? And as you can see, this is the change. This is the commit that they did, right? So what we're going to do now is we are going to try create basically check in or check out this pull request, but locally on the terminal, and see if we can push a commit to this pull request. Not a commit directly to our own repository, to the 2 Degrees Investing organization repository, but a commit that actually gets inside this pull request. And that is something that I believe some of us might have wanted to do and struggle at some point. So let's pop up a terminal. That'll probably be fun. What I'm going to do is I'm going to navigate to that repository that I have here locally. I'm going to do a git pull just to make sure that I am, I have all the latest and greatest. Let me see where I am. Yes, I'm in the right place. Git remote. Let's see if I have my remotes configured correctly. Yes. What I'm going to do now is to make sure that I have, actually, let me show you the branches. So all these commands are something that we have already visited before. So this lesson should be kind of like a review, hopefully. Let's run the command git branch with the flag -vv that should show not only the branch, but also if there is a connection to a remote, it should appear here in kind of brackets. And there isn't something like that. So I'm going to add that with the command git branch -u, which is the short for set up upstream or set upstream. And I'm going to say that I want to create a permanent connection between this branch in which I'm standing and the origin branch and the branch master on the origin remote. So with this, I could rerun the command git branch -vv, and now you do see this additional information here that all it means is that when I do git push, Git will automatically know that where I want to push, if I am standing on the master branch, is to the master branch on the remote origin. What does the remote look like? Let's have a quick look. Again, this is another review with the command git remote -v. You can see that in this case, the remote origin here, origin is just a nickname, is pointing to the 2 Degrees Investing organization, right? So this is the account has privileges to push there. So when I do git pull, actually what I'm doing is remember is a git fetch to get all the metadata from that remote, and then a git merge. So I'm gonna do git pull because it's kind of a shortcut. With that, I will make sure that I have all the changes that come from the master branch on the remote origin. But now we want to work with the pull request, right? So what I do usually, if I'm working with any of you on a particular repository, I check what's the number of that pull request. In this case, the number 21. And there could be, we could do a lot of things manually, but instead what I usually do is I use the command line gh, which is a program that you can install in your computer. And I do check out and the number of the PR, right? So we said it's number 21. I think I forget something here. What did I run? GH, I forgot to say PR for pull request, check out 21. So this GH command line application, so remember, this is a series about working with Git from the terminal. So I want to stay in the terminal. I also use this package for these actions that automate a lot of the processes. But in this case, I want to work from the terminal, so I use the GH program. So I say GH instead of Git, I say GH. And PR is a subcommand of the GH command line application. And then I say what is the pull request that I want to check out. In this case, it's number 21. And as you can see, it has done a lot of work for me. And in particular, this is the one-line thing that makes everything happen. So it has created a reference. For short, it's going to call it patch 2, which is the name of the branch that the user created to make this commit or to host this pull request, including in this case one commit. But internally, Git knows that this is a specific connection to a pull request, right? And this is the trick. So now, this in this case maintainer could inspect the pull request with something like, for example, let's review some commands that we saw before. We could do git show to see what is the last commit. So the last commit here is the message, and here in green is the changes, right? They could do something like git log one line to see how that one change at the top relates to the history of the repository, right? And let's say that they want to add some change. They want to create, let's say, just to make something very easy, let's see, actually I could edit the same file. Let's do git vim readme md. With this, I'm gonna change the dot with say an exclamation mark. So that's the change that the contributor did. I could do git status -s to verify that the file has changed. I could do git diff, and there you will see, that this change from, the red dot to the exclamation mark. So now the next step could be to add this change to the staging area with git add, in this case, readme.md. And now if I do a git status, what I could see is that that file has been added. That's why it's in green. And finally, I could do a commit, but let me first clear this console with Ctrl-L, git commit -m, and the message add bang. Bang. There you go. So now, if I push, what's going to happen? Let's try git push. And this is a bit of the mystery that I wanted to reveal for you, and the beauty of using a dedicated tool to do the job. Because think of the following: if I do git remote, I have only one remote and it's called origin. If I do git remote -v, I see more details. Okay, the configure remote is the one that is pointing to 2 degrees investing. I have here like no information whatsoever that says that I am pointing to a fork that someone created on their own user account. And yet, when I do git push, without any further specification, Git knows where to send that commit, which is to the branch in the account of that user, of that contributor that submitted the pull request. So let's confirm that. So let's go back to the web browser here. So I'm going to refresh this browser, and if I'm lucky, if things work the way they should, I should see that there is now a new commit. And there you go. So you can see now the first commit here was made by this user, right, in their own fork, in their own branch. And now I, as a maintainer in this case, I have been able to extend that pull request very fluidly, right, with the commands, the Git commands that I always have been using, I'm familiar, except this one thing called GH that allowed me to create a lot of connections that automatically work and work fine. I just added my commit, I pushed, and that commit went to the right place. It went to that particular branch of that user. So as you can see, in this particular pull request, even if we are still kind of opening in the discussion if we should or we should not, what I wanted to demonstrate is that there are tools that if we want to go this way, they make the job fairly easy. So I think that's about it. I could also demonstrate how things do not work. If we want to do the configurations manually. One trap in which we often fall is like when we scroll down to the next to the merge button of a pull request, you will see that it says command line instructions. So when you follow these instructions are only they only work when you want to check out that pull request locally and you're kind of fine with it, or extend it, but do not push again to the contributor's fork, but instead you just merge the pull request locally and push directly to master branch on the mainstream repo, which is something we avoid. We instead prefer to use always the GitHub interface to merge pull requests, because sometimes we also gain the benefits of a lot of checks that happen in remote computers like GitHub Actions, that we check that things work as we expected before we actually accept that pull request. So with this, I'm a few minutes early, and I'm hoping to have sparked a lot of questions, a lot of doubts. So please go ahead and let me know what needs to be discussed here.
Okay, I'll say something.
Sure, yeah.
Maybe in a very short, concise way, review everything, because I'm not sure. That seemed like a lot to digest to me. So I'm mostly interested in, so you're using GH because this automatically does some stuff. Can you describe, maybe without getting too crazy, what is that stuff that it's doing? With the understanding that, okay, maybe I don't want to do this manually, but I would like to at least understand what it is doing.
Yeah, absolutely. I think it is worthwhile. So actually, I thought that I understood how things worked until 2 hours before this meetup that I realized that I didn't as much as I did. And then I kind of valued even more these tools that kind of automate processes. So let me show you a little bit. So let's go back to demo. What I'm gonna do here is git. I'm gonna use some shortcuts to work a little faster. I'm now in the master branch. I'm gonna delete the patch branch, and I'm gonna basically now I have no more branches. And I have just this one remote. So, what I thought I could do is, okay, fine, I'm gonna follow these instructions a little bit, right? So what I do is like, I basically create a branch here, git checkout -v, to create the branch and check it out. And I can call it, in this case, it says Mauro Lepore patch 2. I could just call it patch 2 if I wanted. And here explicitly we're saying master because it's like, well, we want this branch to start at master, but it would be the same to not use it in this case because I am actually standing in the master branch. So, okay, fine. I create that branch. Now what I would like to do is to, for example, set up a remote that connects my local repository to the fork of this person. So that, say, okay, I know how to do that. So I'll go ahead and just do it. So I would do git remote add, and then I would say something like Mauro Lepore, which is the name of this user, and start giving the remote URL. So in this case, it's git at github.com Mauro Lepore demo git. That's the URL. So the first thing I would do now is, okay, now I want to fetch all the metadata. Now that I have this connection to the fork of this person, I want to fetch all the metadata. So what I could do is git fetch and the name of the remote that I have just connected. So Mauro Lepore. And so far, you think it should kind of look like it's working. So as you see, I'm bringing all the metadata that this person has in their fork. So now I go, oh, great. I'm going to create a permanent connection between the master branch, between the patch branch locally and the remote branch patch 2. So I'm going to do git branch -u to set the upstream between the branch that I'm standing right now, so I don't have to kind of explicitly say it, and the one on the remote, which is in this case Mauro Lepore patch 2. So again, that seems to be working, right? So branch patch 2 has been set up to track the branch patch 2 from remote Mauro Lepore. So that's all works fine. And now is when I say, well, now I'm going to create a new change and I'm going to push it and it will just work. And I can even confirm that it looks like it's going to work with, for example, let's do git remote -v. Okay, I do have a remote origin. I do have a remote Mauro Lepore. Let's see if there is connections between the local and remote branches. So let's do git branch -v. Oh, it looks like it's working. So my master branch is linked to to origin master, and the patch 2 branch is linked to Mauro Lepore patch 2. So what I could expect right now, if I create a new change, so let's say that I edit, actually I'm gonna do an easier change. Let's touch a new file called A. Let's see the status. As you see, the file 8 is there. Git add A, git commit new A, git status is now clean. So now I say, well, let's push now that I have this change. So let's do a git log now just to confirm. Okay, so branch patch 2 has moved one commit on top of master, right? It's a little ahead. So I'm just gonna push it. And because I have a permanent connection between my local branch and the remote branch on the contributors fork, Mauro Lepore, I expect this to just work. And what I got is that it didn't. So let me, there you go. So here you can see that there is, rejections. At some point, I got one that says permission denied. So let's do, so one of the reasons why it might fail is because I don't have updated the metadata. So, I immediately did git pull to see if I could get stuff from that. Okay, it's saying that apparently there is some changes there that I need to incorporate, and a fast forward is not possible. So I would do git fetch to get the metadata, and then a merge. Git merge, in this case, Mauro Lepore patch 2. No, patch 2. I accept the merge. And now let's see if I can do git pull. And with this, I'm going to continue to fail. Git push. So I tried this a couple of times before as I was trying to learn, and I expect this. Ooh, actually it looks like, let's see, maybe it did work. Okay, it pushed something, right? But I expected it to go to the fork of the contributor. And I think that it didn't. I have just pushed accidentally to the, not to the pull request, I think, but instead I pushed to, let's see. Oh, actually, yes, it is here. Anyway, well, long story short, it is very complex, and as you can see, I don't, not even myself that I work with this all the time fully grasp what's going on. And even if I learn a little more, I find that doing all these connections manually is a lot of work, and it's very easy to get something wrong and then not even understand what was happening now. I don't even understand what's really going on and why I failed before or why I don't fail now. So with that, I hope it can motivate people to choose a tool like they use this package or the GH command line application that automates all these connections for you. Too long of an explanation, but anyway. Maybe it actually makes the point that it's so painful.
Yeah, so essentially you're using the GH command, which comes from GitHub, which like kind of automatically, transparently does all that stuff that you were doing.
Yeah.
Like I think part of the problem with what you did was like you were creating a new branch, but it was based on the master, not on the forked version, and then you had to fetch that data and merge it to get it up to date, blah blah, before you can even think about merging it. But
exactly.
So doing it like all kind of transparently, so you don't have to add the like upstream, like these alternate remotes, which is what like I know you and Jackson, and I've asked Jackson to help me do more than once. But so you don't have to do any of that because GH is kind of transparently doing that.
Exactly. Yeah. So all the setting up the fetching, connecting, pushing, it's all just happens. It's great to know it, and I'm excited to kind of force to learn all these things, to kind of teach them, and also to expose these things that I still don't fully understand. But in the day-to-day work, it's like I just don't want to think about that. I just want to think about the change that I want to make and get past all the configuration shit.
I think it's a bit disappointing that like when you create a fork and then you submit a pull request from that fork to the origin, that the origin doesn't just like automatically make a branch in the origin that maybe has like heavy restrictions, maybe it's forcefully nothing can be merged to the master without. I mean, I don't know. It seems I can kind of understand like you don't want like a random user to be able to create a new branch in your repo, but also it just seems like in a lot of cases that would make a lot more sense.
Yeah.
I mean, like with bigger projects, you end up with like 2,000 branches sometimes or more. If you look at the RStudio project on GitHub, already that has almost 2,100 branches. And I think that if you're allowing any pull request from anyone to create a branch on your actual project and let it get fetched the information, you're going to be fetching like potentially thousands of branches all the time, which is obviously a bit of a hassle.
Sorry, I think we need to move the discussion parallel because it's we are over the time. I guess. Sorry. Yeah, I'm sorry for that. I guess the takeaway is these two workflows, both are fine. One is very complex, but you can abstract the details through tools. And if it's too complex, we can still use the simpler workflow that Alex and ZJ have been kind of pushing from the very beginning, and I think it's just fine. Okay.
Yeah, I mean, I'm also. All right, you guys.
Okay, ciao, ciao.